So this is Chem 101, Lab 2. One part of the lab involves having two pieces of rubber tubing, and we are now going to measure the length of these pieces of tubing, once with a ruler and once with a vernier caliper. So first we'll measure them with the ruler. So we have this clear piece of tubing. We're using the centimeter and millimeter side of the ruler, not the inches. So we're going to lay the piece of tubing just like that. And this one looks like it's falling right, oh no, not exactly, it's not cut in even length. A little bit uneven the way it's cut, but now, proper method in the science lab is to estimate the last digit in between the millimeter marks. So this piece of tubing is 3 point, it's between 3.9 and 4.0 centimeters, or that would be 39 and 40 millimeters. So I am going to estimate that last digit as a 5. So we're going to call it 39.5 millimeters. So I will write that down on my sheet here, data sheet. Okay, here's a second piece of tubing. This one's a little bit bigger. Again, we're using the centimeter side of the ruler, centimeters and millimeters. This one is between 55 and 56 millimeters, or 5.5 and 5.6 centimeters. So it looks a little bit closer to 56. So I'm going to call this one 55.7 millimeters. So now we'll try it with the calipers. And this is designed to give you more precise measurements of small objects. And we're going to use the kind of the pointed ends of this caliper. First we want to make sure it's zeroed. So when I closed it, it got a little bit off, so I'm going to zero it again. Whoops. I'm going to zero it again. And then we will measure our clear tubing first. This is already reading in millimeters. So this says 39.40 millimeters. So I will write that down. Then I will close this again and make sure it's still zeroed. And it is. And then we'll measure our second piece of tubing. And this says 53.01. Now, when you write your sources of error part of your lab report, you may wonder why this was, the first measurement was 55.7 and the second one was 53.01. It made the, I would attribute that source of error to the fact that the tubing is not cut completely straight. So I may have been measuring kind of this end the first time and then maybe that part the second time. So in this part of Lab 2, we are going to measure an index card, the length and the width, with a centimeter ruler and also with the vernier caliper. So let's measure it with the ruler first. And again, good practice in the lab is we're going to measure not only the millimeters, but estimate in between the millimeter marks if needed. So in this case, it looks like this is just a little bit wider than 76 millimeters or 7.6 centimeters. So I'm going to call that 76.1. And that's the width. And now the length. All right, this looks like it's in between 126 and 127 millimeters, or 12.6 and 12.7 centimeters. And it looks like it's a little bit closer to 12.7. So we're going to call it 12.7, 12.77. That would be centimeters, or 127.7 millimeters. That's 127.7 millimeters. All right, let's see what happens when we measure it using the calipers. So the calipers are on and they're zeroed. We'll do the width first. It's 76.18 millimeters wide. Oh, needs to be zeroed. So I will do that. And then going to be just able to capture that, the length of this, hopefully. So I'm getting 126.65 millimeters for the length. That should be good, hopefully.
That's all?
I think so. She just wants. So this is Chem 101 Lab 2, a second part of the experiment here. So in this part of the experiment, we want to demonstrate that the markings on a beaker, here we have some volume markings, these are approximate at best, and in fact it even says approximate volumes. So for some things in chemistry, you need to measure volumes more precisely. And so whenever you need to measure volumes more precisely, you want to use a graduated cylinder, because these are more exact in terms of the volumes. So in this part of the experiment, we want to demonstrate that. So I will put water into this beaker. Up to the 50 ml line. It's not quite there yet. You always read the volume by getting your eye right at the same level as the liquid is. All right, so that is 50 mils, at least according to the beaker. But now let's see if that's really 50 mils when we pour it into the graduated cylinder. And you can see that when you pour that liquid into the graduated cylinder, it's really more like 48 milliliters. And this would be variable because, again, these beakers are not precise enough. So some might be a little under 50, some might be a little over 50. So you want to use a more precise piece of lab equipment like this graduated cylinder if you need to measure your volumes more precisely. Hello again. This is part of Chem 101, Lab 2. So for this part of the lab, we're going to weigh out magnesium sulfate. You may have that at home if you have Epsom salts, using a weigh boat, and a scopula, and the analytical balance. So you can see that the balance right now is reading 0 grams, and this analytical balance reads to tenths of a milligram. We are going to record all of the digits. So first we will weigh the weigh boat. And you always wait a few moments for the balance to stabilize. So this is our final mass here. For the weigh boat, now we're going to weigh out 3 grams of magnesium sulfate. That's close to 3 grams. Could do a little bit more. Okay, so 10862 grams. So this is the mass, of course, of the weigh boat and the magnesium sulfate, and then we will let you calculate the mass of the magnesium sulfate. On your lab procedure, you have a place to weigh out the magnesium sulfate 3 times. So we will do another trial. The balance is still 0. Here's another weigh boat. So here's the mass of the weigh boat. And now we'll again weigh out 3 grams of magnesium sulfate. Notice that you always have the balance doors closed when you're getting your final mass, so that you don't have effects from drafts, air currents. So this is the mass of the whey boat plus the magnesium sulfate.